let's get into graphs for categorical data now. So now that we've talked about how to organize categorical data, we'll explore a few ways of displaying these data. This example, just taken from an example in a different textbook, represents categorical data where each data point is the vehicle color involved in a total loss collision, presumably from insurance information. The way that this bar chart or bar graph was created was we took actually a frequency or a relative frequency distribution. So once we have that, we can represent each count or frequency in a vertical or horizontal bar. In this case, vertical. So each class is represented in the labels down here. So notice that we have 6 classes here. And each one has a frequency or a relative frequency, which is represented in the vertical axis. So those are these values. Okay. Now, if we're, reading this graph, you'll notice that the blue has 25. This one looks like maybe 52. This one's probably 41. This looks like 37. This one's 39, and this one might be 23. Now, this graph isn't all that precise. The vertical axis is going by 5. So 0 is the lowest frequency that's recorded here, or that can be recorded here, and then 5 is the next one. So the bars are kind of in between those horizontal lines. And so we can see that this came from a frequency distribution where the classes were the colors, so blue, green, red, white, black, and gray. And the frequencies are the heights of the bars according to the scale that we have here. So notice that these are whole numbers because we're measuring number of accidents or total loss collisions. And we got that from the graph, but we can also create a graph directly from these. So to illustrate that, I actually want to create a similar kind of graph that's called a Pareto chart. What's different about a bar graph and a Pareto chart is that the Pareto chart organizes the classes from most frequent to least frequent. So it'll look very similar. And here I'm just sketching what the chart should look like. And so I'll use my same scale here. So 0, 5, 10, 15, and so on. I might need more room. Always feel free to adjust your chart as necessary, but make sure that all the numbers are evenly spaced apart if you're using the same amount of room. So each box represents 5. And make sure also that your charts are equally spaced apart as well. So I will go ahead and write my labels in down here. But most importantly, I want to start with the class that has the highest frequency. Notice that's green. So I'll put green here. Next would be red. And then next would be white. No, sorry, black and then white. See, you have to be careful. Black, then white, and then blue, and then gray. And now I'm going to draw my bars again. So for each one, I'm going to draw a bar here of the appropriate height. Make sure that they're the same width as well, because you want to represent just the data from the height, not the width. So green is right here, 52. So that's, that's my green. Red is 41. So up here. Black, that's 39. The number of white total loss collisions were 37. For blue, that's 25. And for gray, that's 23. So some important principles here when you're creating your graphs, whether it's a bar graph or a Pareto chart. Importantly, you should start at 0 for your vertical axis, or if you're doing it horizontally, your horizontal axis. You should make your, let me clarify. Why should it start at 0? Oh, and I guess that didn't start at 0. I guess it started lower than that. Okay, let me just move that. See, that's important. But you need it to start at 0 because if you start at any other number, you may be misrepresenting the proportions. So how frequent relative to other categories that data value is, right? So you want to clearly demonstrate that the number of blue collisions is roughly half of the number of green collisions. If we started at, for instance, maybe if we started at 15, that would not be clear because it would look like this graph would be far greater, or this category would have a far greater frequency than the blue one, even though that's not true, it's half. Okay. Another thing that you should be careful of, making sure you use the same width for each bar, because you don't want to represent your data with two spatial components. So only the heights matter here, not the widths. Make them evenly spaced apart, just so that you're not you're using your space appropriately. And lastly, making sure that you have a legend, that you have everything labeled. Because if you don't have everything labeled, you've lost information. A brief note about pie charts. You may sometimes see pie charts being used. So just to remind you, a pie chart looks like a circle where where the data are represented in terms of relative frequencies, right? So if this is one category, this is a different category, each slice represents the relative frequency of that category. So these only work with relative frequency, whereas the other two, bar charts and Pareto charts, work with both relative frequency and frequency. And the problem with pie charts is that visually it's hard to tell. For instance, if this is a 30%, 30%, 10%, kind of like the distribution of grades in this class, it may be hard to tell the difference between, sorry, give me a sec. It may be hard to tell the difference between 30% and 30%, or whether this is 32% and this is 28%. So small, minute differences, sorry, that's very hard to read. Minute differences can get lost in a pie chart, and it's much easier to tell that in a bar graph or a Pareto chart. So for that reason, avoid pie charts whenever possible.